Sorry about the delay in the video, guys. A few technical difficulties over here. So let's take a look at the formula, as I said at the end of the previous video. When you look at the formula and we look at our three examples, we see 6 factorial, 6 being your n, 4 factorial, 4 being your n, 12 factorial, 12 being your n. So notice on the right side, it starts with n, 6 in the first case, 4 in the second case, 12 in the third case, n minus 1, 6 minus 1, 4 minus 1, 12 minus 1, times n minus 2, 6 minus 2, 4 minus 2, 12 minus 2, times n minus 3, 6 minus 3, 4 minus 3, 12 minus 3, and so on, all the way down to every factorial ending in 3 times 2 times 1, 3 times 2 times 1, 3 times 2 times 1. The larger the factorial, the more middle steps there are before we get to the 3 times 2 times 1. This is our first formula for this unit, and it's the first one that I'm going to have you memorize. Now, when I memorize it as words. N times n minus 1 times n minus 2 times n minus 3, ... 3, 2, 1. Okay, let's flip over to the next page. And example 2 says, evaluate each of the following. So let's get our calculator going and try 7, second function, factorial. Excellent. 1, second function, factorial. 0, second function, factorial. Oh wow, isn't that neat? 1 factorial gives you 1, and 0 factorial gives you 1. This is known as a special rule. There is a proof to it, but at this point we're not going to go through the proof. I'm just going to have you memorize that 0 factorial equals 1. Okay, let's look at D. Let's try it. 10 factorial divided by 7 factorial. So far, so good. What about the next one? 97 factorial divided by 93 factorial. Uh-oh. Okay, now what do we do? Well, here's the problem. Some of the factorial questions can be done directly from the calculator. No problem, you just saw 4 of them. Some of them we have to think back and use our long way, what 7 factorial actually means. So hold on, let's go back and revisit some of these questions to sort of try and help us do the next ones. 7 factorial would mean 7 times 6 times 5 times 4 times 3 times 2 times 1. I think everybody feels comfortable with that. 10 factorial would mean 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 7 times 6 times 5 times 4 times 3 times 2 times 1. Now, when I write it out like I have here in red, what really becomes obvious is that 7, 7, 6, 6, 5, 5, 4, 4, 3, 3, 2, 2, 1, 1. I can cancel because of the repetition from 7 all the way to 1 and from 7 all the way to 1. So that leaves me with 10 times 9 times 8, 720. So sometimes I'm going to be able to do it via the calculator without even thinking twice. Sometimes I'm going to have to go back and write the question out in its long format. So hold on, let's use that logic for E. 97 times 96 times 95 times 94 times 93 ... 321 all over 93 times 92 ... 321. Notice, where is the repetition starting? Well, the repetition from 93 all the way to 1 starts right here on the top, and from 93 to 1 right there on the bottom. So I can cancel all of that out and be left with just 97 times 96 times 95 times 94, which is a beautiful answer of 83,156,160. And that's how you get that answer. Okay, let's take a look at E and F. Okay, what if I just took my finger and I covered up the 3 factorial? So what if I gave you a question that said 20 factorial divided by 18 factorial? Based on examples D and E, we would know, if we were writing it out in long notation, that that would mean 20 times 19, because everything from 18 all the way to 1 would be canceled out. Okay, so the 20 divided by 18 factorial, that's taken care of, but there's still a 3 factorial in the denominator, a 3 times 2 times 1 in the denominator. So 20 times 19 is 380. 3 factorial, or 3 times 2 times 1, is 6. Final answer, 190 over 3. See if we can try the same logic with the 105 divided by 103 over 2 factorial. So if we just saw 105 factorial divided by 103 factorial, you would know that that would just mean 105 times 104. Everything from 103 on would cancel in the numerator and the denominator. In the denominator, we still got a 2 factorial. So 105 times 104 all over 2 times 1. 105 times 104 all over 2. 10,920 over 2. 5,460. Beautiful answer, solved perfectly. Now, can we just add one final thing before this video is done? These factorials that we've just been solving in part 1 of our lesson are called numerical factorials. Perfect. See you for part 2.